Good morning, and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to just follow a complicated probability question, which is sometimes talking about proof. And sometimes we are faced by situations that are quite complicated, but using probability we can understand them and be able to answer the question. For example, show that in a room of only 23 people, the probability of 2 people having the same birthday is just over a half. How many people? 23 people. 23 people in a room. The probability of 2 of them having or sharing a birthday is just over a half. And one of the things that we know very clearly is that the probability of 2 people sharing a birthday, when we add to the probability of 2 people not sharing a birthday, this is equals to 1. The probability of an event happening plus the probability of an event not happening is 1. That means the probability of sharing a birthday, 2 people sharing a birthday, is equals to 1 minus the probability of not sharing a birthday. And I want to underline here is not just 2 people. We are talking of 23 people. And I want to say this. If the first person is selected, he has a probability of 1 out of 365 of being born on that very day that they are talking about, or being born on a specific day. If, and I repeat that again, if one person is selected, the probability of having a birthday on a specific date is 1 out of 36. 1 because he is born on a single day, and within the year there are 365 days. So he was only born in one day, and there were 365 days to be born. So if he was born on only one day, so the probability of having a birthday is 1 out of 365. And therefore, that if he was born on, let's say, a date like today, let's say 23rd of September. If he was born on 23rd of September, that means any other person that will be selected from the group has been left with only 364 days to select from, because the first guy who was selected has taken 23rd of September. So if the second person is selected and the birthday falls on 23rd of September, then they share the birthday. But if the second guy is selected and the birthday falls on any other day apart from 23rd of September, then they don't share the birthday. But there is no way he's going to be born on 23rd of September. Why? Because the question is, show that in a room of only 23 people, the probability of 2 people having the same birthday is just over a half. Having the same birthday. And you can see the probability of having the same birthday is 1 minus the probability of not having the same birthday. So assuming now we pick the first character, the probability of having the same birthday is 1 minus. When the second character is selected, the probability of not sharing the birthday with the first person is now 364 out of 365. If the third one is selected, the probability of not sharing a birthday with any of the two, meaning that this day has been taken by the first guy who was selected, the second guy has taken a day, so leaving behind 363 days to select from. And the probability that even that guy does not share the birthday with any of the two is 363 days out of 365. What does this mean? This means to avoid sharing the birthday with either the first or the second who have taken two specific dates. And I said if the first one was born on 23rd of September, the second one can be born on 5th of January. So these days are not out for grab. For us to have the third person not sharing the birthday, he will have at the disposal his 365 days to select from, but don't touch the two because the two have been taken. That means now 365 minus 2 is 363. If we happen to select now the third character, not the fourth character, he will be having 362 days out of 365. The fifth character, he will be having 361 out of 365. The sixth character, 360 all over 365. This is character 1, character 2, character 3, 4, 5, 6. And already you can see now from 365 we are at 360 and we have considered six characters. And in this case, now we will have a total of 365 minus 23 people, which is 342. But this 342, when you consider the first two, this is character 1 and character 2. You see, the number of days just reduces by 1. Between character 1 and character 2, the number of days simply reduces by 1. When we put in character 3, the number of days will reduce by 2. So 3 people reduces the number of days by 2. 4 people reduces the number of days by 3. So 23 people reduces the number of days by 20 what? Is it 24? Let me say that again. 2 people, the first and the second one, reduce the number of days by 1. 3 people reduces the number of days by 2. So 23 people will reduce the number of days by 22. So the probability that the 23rd person, the probability that the 23rd person will not be, the probability that the 23rd person will not be sharing the birthday with any of all these will actually be 365 minus 22. We'll be having 343. We'll be having 343 out of 365. Now, I would want to say this. This is the probability that at least any 2 people will have a birthday, sharing a birthday, is 1 minus all the probabilities that none of them share the birthday. It means the probability of having a birthday is 1 minus the probability of not having a birthday. And this is the probability of the second character not sharing the birthday with the first character. And the third character not sharing the birthday with any 2. And the fourth character not sharing the birthday with any 3. And of course, we can talk about the second person and the third person and the fourth person and so on and so forth. So In a nutshell, we have the probability of two people sharing a birthday is 1 minus 364 out of 365 and 363 out of 365 times 362 out of 365 times 361 out of 365 times 360 out of 365 times 359 out of 365. And because we cannot list all of these, we say times and then continue, and the last probability will be 343 out of 365. We say this, and in a nutshell, this one, if you take time to calculate, it will be 1 minus all this, which is basically around 0.51. And I want somebody to just try that and find out whether this is true, which is just, and this is just over a half, because 0.51 is simply over a half, because a half is 0.5. And that is true. It is a complicated question, but it is worth it. If you have understood, well and good, thank you. But it is a question that is quite tricky and complicated. But that is it. Thank you. Let us meet in the next video.